Okay, so for this problem, we have sine of an inverse cosine of 1/2 and an inverse sine of 3/5. So what we want to remember is that each of these inverses is just an angle. So this inverse cosine of 1/2 is really like your alpha, and this inverse sine of 3/5 is really like your beta. So ultimately, I'm just doing sine of alpha plus beta, which is going to equal sine alpha cosine beta plus sine beta cosine alpha. So let's see. The blue one is cosine alpha already. Like the cosine of alpha is 1/2. And the red one, inverse sine of 3/5 equals beta. That means the sine of beta is 3/5. So that side is just going to be 3/10. Now, for the other side, we need to draw some quadrant triangles. So for cosine inverse of 1/2, I need to draw an angle in quadrant 1, because cosine is positive in quadrant 1, where the cosine is equal to 1/2. And I could say that inverse cosine of 1/2, that's just a pi over 3. It's a 60-degree angle. So I could also say that this is 60 degrees or pi over 3. And then I could take the sine of pi over 3 or the sine of 60 degrees. But I can see from my blue quadrant triangle I drew that the sine of 60 degrees, the sine of pi, the sine of alpha is root 3 over 2. So for that angle, I didn't need to draw the quadrant triangle because I could figure out the value. But for the red one, I do need to draw the quadrant triangle. So inverse sine of 3/5, inverse sine is positive in quadrant 1. Draw this for the sine opposite over hypotenuse, is 3 over 5. And then Pythagorean triple tells me that the bottom of that triangle is going to be 4. So I need the cosine of beta. So this is beta. Cosine of beta is 4/5. So altogether, I have 4 root 3 over 10 plus 3 over 10. And I'm going to write that as 3 plus 4 root 3 over 10. And then you can type that in to get the decimal that you want.